past 20 years, orbiters and rovers have brought us an unending string of evidence that Mars once had water that could have meant habitability. From seeing now dry riverbeds to finding minerals that can only form in liquid, most scientists are ready to agree that Mars once, long ago, had water. But this isn't to say there isn't controversy. We still don't know if Mars had long-lasting seas that might have supported the evolution of life. Perhaps water was only transitory, raining down repeatedly with impacting meteors and comets before rapidly slipping away. This question, how long did the red planet remain wet, is now the question being asked by researchers all across our pale blue dot. In searching for answers, PSI senior scientist Catherine Weitz went looking in the Martian dirt.
Using orbital images, we identified clay-bearing sediments within northern Ladon Vallis, southern Ladon Basin, and the southwestern highlands around Ladon Basin.
Here on Earth, we have learned that our world's history is recorded in layered rocks, with global events leaving their mark in every outcrop in the world. By studying these sedimentary layers deposited over millions of years, researchers can identify local phenomena like floods and fires and spot catastrophes like volcanic eruptions that spread ash around the planet. The same science that allows us to understand our Earth, the study of sedimentary rocks, also works on any other world that has weather, including worlds like Mars. Modern Martian weather deposits dust, sand, and ices on the surface, but deeper layers show us that the past was much less boring. Image analysis by Weitz and her colleagues revealed stunning deposits from the past that included clays and the kinds of rocks called mafic rocks that are rich in magnesium and iron. Some of these minerals, like the clays, required water to form. The distribution of these materials, particularly in the Ladon region, is consistent with water that stayed long enough to shape the world.
Colorful, light-tone, layered sediments that display relatively low bedding dips and contain clays across 200 kilometers in distance are evidence that a lake was most likely present within Ladon Basin and northern Ladon Vallis. The low-energy lake setting and the presence of clays support an environment that would have been favorable to life at that time.
The late Noachian is one of Mars's geologic periods. It's Mars's own version of the Paleozoic we had on Earth. And like on Earth, it was a time marked by abundant surface water and abundant meteor strikes. This era stretched from about 3.7 to 3 billion years ago. Over time, our worlds diverged, with Earth remaining a wet, warm planet while Mars became the frozen desert we see today. This transformation took place during Mars's Hesperian to Amazonian period, which stretches from about 3 billion years ago to today. Weitz's team looked for landscapes that could define when Mars was wet and water flowed, and when water's fluvial forces changed the landscape.
We found that the Ladon Basin region within Margaritifer Terra records a long history of flowing water beginning relatively early in Mars history, around 3.8 billion years ago, that continued until up to 2.5 billion years ago, which is considered relatively recent.
To understand these images, we have to understand the processes that build up Mars's surface and then erode it back down. From the building up of clays to the impact of asteroids, multiple factors all played their own important roles.
The clays initially formed early in Mars history, perhaps when there was water on the surface that could alter volcanic rocks into clays. The Holden and Ladon basins formed by large impacts very early in Mars history, and there could have been hydrothermal activity resulting from these impacts that would have formed some clays in the region.
Materials also had to form in the right places to take advantage of the wonderful water, and water, like so many other things, flows downhill. Ladon Basin is a giant crater with highlands and mountains surrounding a lower, flatter floor, and the water flowed down from the highlands towards the floor, producing all the valleys that surrounded the basin.
After the clays formed in the highlands, water eroded through the highlands and carried the clay-bearing sediments downstream, where they were deposited into the light tone layer deposits we now see from orbit.
And clays aren't just a cool, complex form of dirt that you can turn into pottery. Clays are also environmental stabilizers and a place where nutrients can be found. Stability, nutrients, water. These are also the things of life.
The presence of clays indicates an environment favorable for life because clays form and remain stable under neutral pH conditions where water persists long-term that minimizes evaporation to form other minerals like sulfates. The lake setting and presence of clays within Ladon Basin and northern Ladon Vallis point towards an environment that would have been favorable to life at that time.
At this point, we can't actually go fossil hunting on Mars, but that possibility is no longer a sci-fi dream. The work of Weitz and her team helps us understand where the conditions, water, clays, and minerals, once could have supported life. They have told us that these conditions could have even existed for over 1 billion years. Now we just have to wait and see which rover or human gets to go fossil hunting first.